Hi, my name is Ruairi. For today's GSC at Home, we're going to be talking about brilliant bridges. We're going to be building our own bridges, we're going to do a science experiment to test them out, and we're going to learn exactly what makes a bridge brilliant. So let's get right to it. So I've been presented with a problem. I have two imaginary hills here separated by a rushing river, and I've been told I want to cross from one over to the next. And to do that, I'm going to need to build a bridge. Now, I'm in my kitchen today, which means I don't have any bricks or anything, but instead we're going to build a bridge out of just a sheet of paper. I think I could use your help for that, so if you want to pause the video and play along, grab yourself some A4 paper, also build something to cross between. I've made 2 stacks of books. You could also just push 2 tables together, anything that leaves you with about a foot to cross. And lastly, we are going to be testing our bridges to see how much weight they can hold. So you're going to need some things to add to our bridge to weigh them down. This could be everyday items, anything you can add one at a time, ideally something like pennies or batteries. I'm going to be using a stack of teaspoons. Okay, so this is going to be an experiment, so follow along with me and we're going to build 3 different bridge designs out of paper that we can test and see which is the strongest. We're going to need our 3 bridges, so let's get started on building. So if you grab your paper, we're going to build our first bridge. We're going to take 1 sheet of A4 paper and you're going to lie that flat down on the table. And that's you done. That is our first design. It is a really simple one, so just stick that to the side and we'll get on with the next bridge. Second bridge is going to be a little bit different. We're going to take a sheet of paper and we're going to lie it down so that the long edges are at the top and bottom. We call this landscape. And we're going to just fold it twice. The first fold, we're going to go at the bottom. We're going to fold it about 1 inch up from the bottom like so, and have the paper point up in the air. And then we're going to spin it around, and from 1 inch from the bottom again, we're going to do just the same kind of fold. So we end up with this kind of trough design here. That is our second bridge ready to go. So we'll stick that with our first. And then we're going to make a third bridge design. We're going to take our paper and lie it down landscape again. And this is going to have a few more folds. The way we're going to do it, we're going to start at the bottom again, and we're going to fold less this time. We're going to fold about maybe 2 centimeters down on itself. Then we'll take our paper and flip it around. And we're just going to fold that edge, about 2 centimeters, back on itself. Like that, revealing our original fold. Then we're going to flip it round and fold it again just the same. And we're going to keep folding like this, back and forth, until we get to the very end. It's just like you might have made a paper fan before in the past. So, take your folded bridge and lay it down on the table and put it to the side. That is us made 3 bridge designs out of paper, and we're now going to test them. So this is where we get to the experiment. In preparation for our experiment, we're going to do one more thing. We're going to make a results table. So at home, get yourself a pen and paper, and we're going to draw a table. On the left hand side, we're going to have a column for each of our bridges, bridge 1, bridge 2 and bridge 3. And on the right hand side, we're going to leave room to write down how many weights each of our bridges held. This is going to be where we're going to write down what we learn. Scientists like to write down what they learn so that they can share what they learn with others. So make sure to make yourself a table and fill in your results as you go along at home. Okay, on to the experiment. So we're going to get to test our 3 bridges, and we're going to test them all in the same way. To test a bridge, you're going to lie it flat on top of your gap, and you're going to add 1 weight at a time to the middle until your bridge collapses and fails. When it does, take your pen and paper and write down exactly how many weights you got to before your bridge collapses. Alright, so I'm going to start with this bridge and we're going to see how they all do. So let's get testing. Bridge number 1, teaspoon. Not very good. Let's hope the other bridges do better. Bridge number 2. 1. 4. lastly, bridge number 3. Let's test bridge number 3. 1, 11. How about the teaspoons? So how did your bridges do? If they're anything like mine, you'll have found that the first bridge was not very good. The second one was a little bit better, and the third one was the best. But why is that? Well, it all comes down to what we call engineering. Now, for a bridge to work, it needs to withstand 2 key forces: compression and tension. Compression is a squishing force, kind of like squishing a spring. Too much squishing on our bridge and our bridge will buckle and collapse. Tension is a pulling force on a bridge, and too much pulling on our bridge and it could snap. It's important to remember that our bridges were all made of the same material, just one piece of paper. So it's not the material that made the difference, but how we folded it that changed how our bridges could withstand compression and tension. Now, our first bridge is really flimsy, so it doesn't work very well. It bends very easily out of shape when we add weight. But just with 2 more folds, and our second bridge did much better. These second folds add some rigidity to our bridge and allow it to withstand a much greater load. Our first flat bridge design is really flexible and flimsy. As soon as we add one weight, it bends out of shape and it falls down on our table. But with just a little bit of engineering know-how and a couple of folds, we can make our second bridge a lot more rigid, and it can hold a far bigger load. But it was the third bridge design that seemed to work the best in my tests. In fact, with all the teaspoons in my kitchen, I couldn't get it to budge. How does that bridge deal with compression and tension? Well, we said earlier that our bridges will fail whenever too much compression or tension builds up focused on the one area. Our bridges are strongest when they spread that force. And our third bridge does that in a really clever way. By folding our bridges, we've managed to bunch it up and allow more of that paper to deal with that load under each of our weights. In other words, more of our paper is being usefully used to hold up each weight. And this allows for our compression and tension to be dealt with by the whole bridge and not just one little bit under our spoon. Making folds like these is just one thing engineers do to strengthen their materials. Next time you're out and about, have a look around at some bridges and buildings and see if you can see what they've done to make them strong. Are they all held up by big thick beams? Are they always flat? Are they sometimes curved? Can you see any familiar shapes that seem to pop up again and again? We want you to be inspired to build some brilliant bridges of your own at home. So grab some more paper, maybe some tape this time, and see what you can come up with. Well, that's all from us today at GSC at Home. Thanks for helping me test out my bridges. Remember, you can take pictures of your experiments and tag us in them using the hashtag GSC at Home. We'll be back again tomorrow at 10 AM with more GSC at Home. But until then, have a great day and good luck with all your brilliant building.